Geometry, Lesson 4.6, we'll be talking about right triangle congruence. No vocabulary, but we do have 4 theorems. These theorems are all concerning right triangles. Don't put these in your notes yet. You'll see what we'll be doing in the next few slides. So what I want you to do is take some paper out, and on one sheet of paper I want you to draw 6 pairs of congruent right triangles. Then I want you to put the right angle in each, so they should look just like these 2 triangles, and you need 6 pairs of them. So on your paper you'll have something that looks like this. You'll actually have 12 triangles. Yours can go vertically. So go ahead and pause the video and get that done, and then come back. Okay, welcome back. We're going to begin with our first set of triangles. So next to one pair of triangles, mark the number 1, and then I want you to do what I want you to do is mark both pairs of legs congruent. So use hash marks to do this, and I just picked AC congruent to DF and BC congruent to EF. You can have the hash marks in any direction. Just make sure you are not marking the hypotenuse. So that's our first set of triangles. Now our second set, label this number 2. I want you to mark one acute angle and the adjacent leg on both triangles. Remember not to mark the hypotenuse. The hypotenuse is not a leg. You could also mark angle A and the leg next to that, and angle D and the leg next to that. The third pair of triangles, we're going to mark one acute angle and the opposite leg. So you can mark this angle and the opposite leg, so angle B and leg AC, and then angle E and leg DF. Or you could mark angle A and leg BC and angle D and EF. Number 4. Mark one acute angle and the hypotenuse. So you can mark either angle B or angle A, and just make sure that you have the same angle marked in congruence on the second triangle. Now for number 5, mark both pairs of acute angles. And for the last pair, mark one pair of legs and the hypotenuse. So you can mark BC and EF, or you can mark AC and DF, and go ahead and show that your hypotenuse in both the triangles is congruent. Now going back to your first set of triangles. So this will be triangle set number 1. Let's take a look at the triangle and what we would use to solve this congruence between both triangles. So it says here to write the congruence postulate or theorem used to prove them congruent. Well, we have a side, and we have the 90-degree angle, and we have another side. So side, angle, side. So up on the top or next to your triangle somewhere, you can actually put it in between the triangles. Wherever you have room, you will put SAS. Now what I want you to do is mark through the A, which is the right angle, and mark through one of the S's, and replace the S with an L, and replace the other S also with an L. So we'll go ahead and we'll strike through this one also. And SAS becomes leg, leg. Now in the second set of triangles, these triangles can be proved congruent by angle, side, angle. So if we're looking at angle B, side BC, and then the right angle, or in the opposite direction, it doesn't matter. So angle, side, angle, and it tells us to remove the A from the right angle and the S from the side, and we'll have the acute angle left, and we'll replace the S with L, and ASA now becomes LA. For your third set of triangles, we have here angle, angle, side. So that's AAS, and if I take away the right angle and one of the sides and rename it L, we end up with AL, or in your book you'll see that they call it LA. So angle, angle, side equals LA. For your fourth set of triangles, we had angle, angle, side. This time the side is actually the hypotenuse. So we cross out the right angle and the side, and we end up with the acute angle and the hypotenuse, which your book calls HA. So AAS becomes HA. Now number 5 is 3 angles in congruence. And we've talked about this before. We cannot use 3 angles or AAA to prove congruence because they could actually have the same angle measure but shorter or longer sides. So we will not be using this for congruence. And number 6 is side, angle, side with the hypotenuse. If it was side, angle, side using AC and DF, we could not use this at all. And we've talked about SSA not being used in high school geometry. However, with right triangles, we can use the hypotenuse and the leg to prove congruence. So this congruence theorem will be HL. You can use that for right triangles only. So we had all 6 pairs of our triangles named, and this is an example of what you could see in your notes, something similar. This is what should be in your notes, not just the theorems, but what the theorems compare to. So SAS is LL, AAS is HA, ASA and AAS are both LA. So they're a leg and an angle. They're just different legs and different angles. So the leg-leg congruence theorem. If 2 legs of one right triangle are congruent to 2 legs of another, then the triangles are congruent. And that is LL, and that's the theorem that allows LL. Remember, when we say legs, they are not the hypotenuse. Hypotenuse angle congruence theorem, HA will be a hypotenuse and one of the acute angles. It will not be the 90-degree angle in your triangle. Leg angle congruence theorem. This will be one of the legs, either one of the legs, and either one of the acute angles. Now this is similar to, these theorems are all somewhat similar to each other, but just follow what the drawing tells you. And the last one we have is the hypotenuse leg. This is the one that stands alone as right triangle congruence. So it has to be hypotenuse and either leg BC and EF or legs AC and DF. Let's take a look at example 1. This is a proof. This is a fairly long proof, but it asks us to prove that a segment from the vertex of an isosceles triangle to the midpoint of its base divides the triangle into two congruent right triangles. This triangle is actually used in quite a bit of the theorems that will be forthcoming, and it uses a lot of information that we already know about. So we're given the isosceles triangle ABC. It has sides BA and BC that are congruent. We're told that M is the midpoint of AC. We're going to prove these two right triangles. So I'm replacing the given in my first statement, and I'm going to write the proof in what we have to prove in the last statement. And once we know that we have a midpoint, we're now going to set out to prove congruent segments. And AC is basically divided by the midpoint M. So AM will be congruent to CM. And that's the definition of a midpoint. MB is congruent to MB. And that's reflexive property in congruent segments. One of the things that you should always look for in a theorem is reflexive property, one of the easiest things to name. Our goal here is to create these two congruent triangles. So we already have some sides, so we can now say that we have another set of sides, which was AM and CM. And now we know we have the sides that are the reflexive property. We now have three sides of our triangle. And we can state that the triangles are congruent. Triangle AMB is congruent to CMB by side, side, side. Now let's pick the pieces apart, because we have to prove right angles. So, angle 1 and angle 2 are the angles we're looking to prove. So let's begin with those. We can say that they're congruent because of CPC TC. And if you notice, they're on a line together. They're linear pairs. So angle 1 and angle 2 are supplementary. That's the linear pair theorem. And why are we using supplementary here? Well, because we want 90-degree angles. So angle 1 and angle 2 are right angles. And that is the congruent supplementary angles are right angles. And we can now state that triangle AMB and triangle CMB are congruent right triangles, and that's because of the definition of a right triangle and because of step 4, which was side, side, side. Sorry, skipped a slide there. So your homework for this lesson is numbers 1 through 13, number 17, 19, 24, and some of the cumulative review, number 36 through 40. Be sure to do the cumulative review. It's important for the next lesson. I have a word bank for number 17. I tell you that you have 5 steps and reasons, and I have also numbered 2 of those steps. So when you're doing your formal proof, you can plug those in there and it will help you do the proof. This is the word bank for number 19, also 5 steps and 5 reasons, and 2 of these, 1 reason and 1 statement is numbered. And number 24 is also 5 steps and 5 reasons, and I've numbered 1 statement and 1 reason also. So, this is a shorter lesson, should be fairly easy to understand. Hopefully this has helped, and contact me if you have any difficulties. Have a blessed day.